Hey everyone, today we are going to solve the Daily LeetCode challenge of 25th January 2024. And the problem statement is longest common subsequence. So let's first understand the problem statement. So according to the problem statement, we have been given two strings, text1 and text2. And we have to find the length of the longest common subsequence. Now let's first understand what is a subsequence. Okay, subsequence is selecting elements by maintaining their relative order. Now, what do I mean by maintaining their relative order? Let's see over here. So if I take the example of text1, then is A, D, E a subsequence? So the answer is yes. Why? Because A belongs to text1, D belongs to text1, E belongs to text1, right? Additionally, I have also maintained their relative order. What does it mean? See, A is appearing before D and E in text1, and in the subsequence which we have written, A is appearing before D and E in the subsequence, and it is followed by D, which is appearing before E. Similarly, here we have written D before E. So it is maintaining their relative order. It means the order in which they appear in text 1, in the same order they have to appear in the subsequence. Now, if I ask that is D A a subsequence, the answer would be no. Why? Because in text 1, A is appearing before D. But in the subsequence, we have written A after D. So this is not a subsequence. Instead, AD could be a subsequence. Why? Because we are maintaining the relative order, correct? Now let's write some of the subsequences of text 1. So we can have A, we can have B, we can have C, D, E. Then we can have AB, AC, AD, AE. Similarly, we can have BC, BD, BE. Then we can have CD, CE, A, B, C, A, B, D, A, B, D, E. Then we can also have A, B, E, A, C, E, A, B, C, D, A, B, C, D, E. Similarly, you can write all the other subsequences on your own. So these are some of the subsequences of text 1. Now let me write some of the subsequences of text 2 over here. So we will have A, C, E and A, C, A, E. Then we will have A, C, E. Fine. Now, what have they asked in the question? They have asked us to find common subsequences, right? Now, what does it mean? It means that which is same in both text 1 and text 2. So let's see, is A a subsequence of text 1? So yeah, we have A. So we'll simply move forward. So do we have C? Yeah, we have C. Do we have E? Yes, we have E. Do we have AC? Yes, we have AC. Do we have AE? Yes, we have AE. Do we have ACE? Yes, we have ACE. So these encircle subsequences of text 1 are common in text 2. Okay, so these are the common subsequences. Now we have to find their length. Okay, so let's see what's the length. Length is 1, 1, 1, 2, 2, and here it's 3. Similarly, it's 1, 1, 1, it's 2, it's 2, it's 3. Now they have asked us to find the longest common subsequence, right? Now what does it mean? It means that we have to find the max of their length. So what is the max? The max is nothing but 3. So 3 would be answer. And what is it? It is, we are getting ACE by selecting this ACE from text 1, and we are getting ACE, which is nothing but the text 2 itself. And this is the subsequence which is common to both of them, and that has a length of 3. Okay. Now let's understand how are we going to solve this problem. So if we are given two strings as text1 and text2, then for each of the characters of text1 and text2, we are having two options. What are the two options? Either this, if I'm present at this A, then either this character is going to contribute to my subsequence or it is not going to contribute to my subsequence, right? So it is nothing but take and the not take approach. Fine. That is, either this A will get added to our subsequence or it won't get added to our subsequence, right? So we are having options, and whenever we have options, we make use of recursion. Correct? So let's say if I'm present at an index I, which is the pointer of text1, and another index is J, which is the pointer of text2. Then I have two options. What are the options? Either I'm going to take the values of this ij or I'm not going to take the value present at ij, right? Now, when am I going to take the value present at my ith pointer and jth pointer? So let's see over here. in my ith pointer I have a, and in my jth pointer I have a. So whenever they will be equal, right, then only we are going to add it to our subsequence. Otherwise, we won't add it to our subsequence. Why? Because we want to get a common subsequence. Therefore, whenever we'll get values present at I and j are equal, then only we will add it to our subsequence. Otherwise, we won't add it to our subsequence. So here you can see that the value present at I and j are a, which is equal. So what we will do, we will add it to our subsequence. And since we are going to add it to our subsequence, it will increment the length by 1, right? Because we have added a value. So what we'll do, we will increment the length by 1 and we'll move both ith and jth pointer forward. So what it will be? It will be I plus 1 and j plus 1, correct? Now talking about the not take condition. So what we will have in the not take condition? So this was the take condition, right? Now let's talk about the not take condition. Not take. Okay. So when are we going to take the value present at ij? Then value at I is equal to value at j. Then only we are going to have the take condition. Otherwise, when we will have the not take condition, when the value present at a, value at ith index is not equal to value present at jth index. If their values are not equal, so if now let's see, if I have my ith pointer at b and if I have my jth pointer pointing to c, then the value b and c are not equal. So there is no point of adding these two to our subsequence. Why? Because they are not equal. So we won't get a common subsequence if we will add b and c, right? So what we will do, in the not take, again we will have two conditions. What are the two conditions? Let's see the first one. What we will do is we will increment the ith pointer. So what we'll do, we will increment the ith pointer and the jth pointer will remain as it is. Otherwise, what we will do, the ith pointer will remain as it is and the jth pointer will increment by 1. Why? Because let's see, if we have a, b, c, d, and here we have a, c, e, correct? Now my ith pointer is at b and my jth pointer is at c. Now these two values are not equal. Now, if I'll increment my jth pointer and if I'll check that is this b and e equal, so they are not equal. Again, I'll increment my jth pointer. So I have reached the end. It means that I have completely exhausted this string. So I won't have any more string left. So I'll simply return a 0. And till now, what is the length of the common subsequence that I have got? It is nothing but only 1. Because till now we have got only a in common, right? And nothing else. But if you'll notice that the correct answer is 3. Why? And why are we not getting 3 from here? Because we are only incrementing the jth pointer when it's not equal, right? And by doing so, we miss this c and we miss this e as well. So what we will do is, whenever we won't have equals, so my ith pointer is here, my jth pointer is here. In one case, I will increment my jth pointer. So it would be a, c, e, and my jth pointer will point over here and the ith pointer will remain as it is over here. And in the second case, what I'll do, my jth pointer will remain as it is here and I'll increment only my ith pointer. So I'll have a, b, c, d, e, and my ith pointer will point to this c. And since the jth pointer here was as it is, so what I'll have a, c, and the jth pointer was at c itself. So here I can see that the value present at my ith and jth pointer are equal. Then we will again increment these by 1. So it would be pretty much clear when we'll do a dry run that why are we skipping some of the characters of text 1 and why are we skipping some of the characters of text 2. Okay, now let's understand that what are we going to add over here. We will simply add a 0. Why? Because when are we going to have this not take? When the value aren't equal, right? And we are not going to take it to a subsequence, so they won't add any length to a subsequence, right? So simply we will add a 0 and we'll make a recursive call. Now, when I'll get an answer from this left call and from this right call, then what I have to do, I have to return the max. That is, I have to return the max of this part and this part. Okay. Why? Because we have to find the longest length, right? So at each step, we will be returning the max of this left answer and this right answer. Now, talking about what would be the base case. So since we are starting from the 0th index of text 1 and the 0th index of text 2, right? So what would be the base case? The base case would be either my ith pointer, which is present at my text 1, and the jth pointer, which is iterating over text 2, right? So either my ith pointer has reached the end or my jth pointer has reached the end. So what would be the base case? It would be if my ith pointer is equal to text1 dot size, or my jth pointer is equal to text2 dot size. In that case, what we'll do, since we have exhausted the string, so we don't have any more characters left, right? So since we don't have any more characters left, so we can't add it to our subsequence, so they won't add anything to our answer. So we'll simply return a 0. So this would be the base case. Now let's quickly do a dry run so as to get a better understanding. So we'll start from the 0th index. This is the ith pointer. This is the jth pointer. So ith pointer is over here and the jth pointer is over here. Okay. Now we will check, is the value present at my ith pointer and jth pointer equal? So we have a in text1 and we have a in text2. So they are equal. So what we will do? We will add a 1. Why? Because we are going to take it to our subsequence. So they will contribute to its length. So we'll add a 1 and we'll move to the next index. That is, we will increment both of our pointer. So it would be I plus 1 and j plus 1. That is nothing but 1, 1, right? Whenever we will get equal, we will increment both of our pointers. So now our ith pointer is over here and our jth pointer will be over here. Okay. Now we will check, is the value present at my ith pointer and jth pointer equal? So I have a b over here and I have a c over here. So they are not equal. So what we will have? We will have two not cases. Now first, what is the case? We will skip the characters of text2 and the characters of text1 will remain as it is. And the second case would be, we will skip the characters of text1 and the character of text2 will remain as it is, right? So first what we will do is skip the character of text2. So this will remain as it is as 1 and this will become 2. Now we are not going to add anything. Why? Because since we have skipped it, right? We are not going to take it to our subsequence. This is a not take case. So it won't contribute to the length of the subsequence. Now we will check that our ith pointer is at 1. So we are at B and my jth pointer is at E. Are these two values equal? So they are not equal. So again, I'm going to have two not take cases. So in the first case, what I'll do, the ith pointer will remain as it is. So this would be 1 and the jth pointer will increment. This would be 3. That is, we have skipped the character of text2. Now you can see over here that we have completely exhausted the text2. Why? Because there is no index 3 in text2. So since there are no more elements, so it can't contribute to the subsequence. So what we'll do, we'll simply return a 0. So we have got a 0 from this left call of 1, 2. Now let's explore this right part. So what were the two cases? Either I'm going to keep the characters of text2 or I'm going to skip the characters of text1. So we are still left to process this part. So let's complete this one. So what I'm going to do, I'm going to increment my ith pointer. So this would be 2 and the jth pointer will remain as it is. So this one will be 2 only, correct? Now we'll check that is the value present at the second index of text1 and the value present at the second index of text2 equal. So here I have a C and here I have a E. So they are not equal. So again, I'm going to have two not take cases, right? What would be the first one? The first one would be skip the characters of text2. That is, increment the jth pointer. So this will be 3 and this would be 2 itself. Now again, you can see that we have reached an index 3 which doesn't exist in text2. So we'll return a 0. Now we'll explore the right call for this 2, 2. Now what would be the right call? The right call would be skipping the characters of text1, right? So this would be 3 and this would be 2. Now we'll check that is the value present at the third index of text1 equal to the value present at my second index of text2. So D is not equal to E. So again, we are going to have two cases. What would be the first case? First case would be skip the characters of text2. So it will remain as I and this will be 3. So again, you can see that third index doesn't exist. So we'll return a 0. And over here, what we'll do, ith pointer will increment and the jth pointer will remain as it is, right? Now we'll check that is the value present at the fourth index of text1 and the value present at the second index of text2 equal. So we have a E over here and we have a E over here and they are equal. So what we'll do, we will add a 1 and we will move to the next index. And what is the next index? The next index will be 5, 3. Now you can see that fifth index doesn't exist in text1 and third index doesn't exist in text2. So I'll simply return a 0. Now we have got a 0 over here. 1 plus 0 is nothing but 1. And at this point, we'll find out the max of 0 and 1, which is nothing but 1. So from here, we are getting 1. Now I'll find the max of 0, 1. So it would be 1. So we'll return 1 from here. So what are we going to return from here? We are going to return 1. Now you'll notice that the value present at 1, 1 was what? It was B and C and they were not equal. So we were supposed to have two not take cases, right? So we did the first not take case over here, which was skipping the characters of text2 by incrementing the jth index. Now what we have to do in the second one, we have to skip the characters of text1 by incrementing the ith index. So we will have 2 over here and this will remain as it is, right? So now I'll check that the value present at the second index of text1 is C and the value present at the first index of text2 is also C and they are equal. So what I'll do, I'll add it to my subsequence. So I'll get a length of 1 and I'll move both of my ith pointer and jth pointer. So this would be 3, 2. Now the value present at the third index of text1 is D and the value present at the second index of text2 is E. and they are not equal. So I'm going to have two not take cases, right? The first one would be to skip the characters of text 1, right? So I'll move the jth pointer, so it would be 3, and ith pointer will remain as it is, which is 3. Now you can see that we have completely exhausted text 2, so we'll simply return 0 from here. Now let's explore the second case. Now what we'll do in the second case, we will increment the ith pointer, that is, we'll skip the characters of text 1. So this would be 4, and this would remain as 2. Now we'll check that the value present at the fourth index of text 1 is E, and the value present at the second index of text 2 is also E, and they are equal. So they are going to be a part of our subsequence, so we'll add a 1, and we will increment both the pointers. So this would be 5, 3. Since again we have reached the end, so we'll simply return a 0. So 0 plus 1, so 0 plus 1 will give us 1. Now from here we'll return 1. Now the max of 0 and 1 would be 1. So this would be 1. Now 1 plus 1 is 2. We'll return a 2. We'll return a 2. Now at this point, we will find the max of 1 and 2, which will be nothing but 2. So this would get replaced by 2. Now 1 plus 2 is nothing but 3. So we'll return a 3 and we'll return a 3, which is the answer. Okay. Now let's quickly code this. So let's write a function, find longest common subsequence. And we are going to start from the 0th index of both text1 and text2. We will pass text1 and text2, correct? Now let's complete this function find LCS. So it is going to give us an integer. This would be the ith pointer. This would be the jth pointer. And we are going to pass the string 1 and string 2, correct? Now if I becomes equal to s1 dot size, or j becomes equals to s2 dot size, in that case, what we have to do, we have to simply return a 0, because since there are no more characters, they are not going to contribute to our answers, right? Now we are going to have a take case and not take case, right? So when are we going to have a take case? When the value present at my ith pointer is equals to the value present at my jth pointer, then only I'm going to add it to my subsequence, right? So what I'm going to have is a take case. So let me write take over here. So we will have take as 1 plus find LCS. And what we will do, since we have taken the value present at my ith index and jth index, we will increment both the pointer. So this would be I plus 1, comma, j plus 1, and we'll pass on the string 1 and string 2. And what we'll do, we'll simply return take from here. Otherwise, we are going to have two not take cases. First, what are we going to do? First, we are going to skip characters of S2. And after that, what are we going to do? We are going to skip characters of S1, correct? So what do I mean by skipping the characters of S2? It means that I'm going to call the recursive function and the ith pointer will remain as it is, whereas I'll increment the jth pointer and I'll pass on S1 and S2. Now, what do I mean by skipping the characters of S1? It means that the ith pointer will get incremented, jth pointer will remain as it is, and I'll pass S1 and S2 over here. Now, what do we have to do now? Here you can see that what we were doing, we were finding the max of both the not take cases, right? So what we'll do is we will find the max of these two cases. That is, from here we will return the max of these two cases, right? That's it. Now let's run it on the given test cases. So you can see that it's giving the correct answer. However, if we will submit it, it will give us a TLE. So let's memoize it. So here you can see that what are the parameters that are getting changed in this recursive function. I is getting changed. Here you can see that we are incrementing I, as well as j is also getting changed, right? So what we will need is a 2DD. So we can create a vector of vector int. And what would be its size? Its size would be the size of text1. So let's take int n as text1 dot size and m as text2 dot size. Correct? So let's call it as memo, and its size would be n cross m, right? So we'll have n, and over here we'll have m. And initially all the values would be -1. Fine. Now what are we going to do? Simply we can pass this memo over here, and let's write vector of vector int memo, and we'll have to pass it in the recursive calls as well. So let's add memo over here. Now say for example, if I have already calculated a value for the ith index and the jth index, Then what does it mean? It means that if it's not equal to -1, then what we'll do, we'll simply return that value. So we'll return memo of ij, correct? And over here, what we will do? Over here, we will add this value directly to memo of ij and we'll return memo of ij. So we don't need this take anymore. And here what we can do is, before returning, we can add this value to memo of ij. Now let's run and check whether it's working fine. So it's giving us the correct answer. Now let's submit it. So it got accepted. Now this was the memoized code. Now let's write the tabulation code as well. So let's comment this part and let's convert it to tabulation, right? So let's remove this line number 28. So here what we were doing is we were traversing over both the string s1 and s2 using two pointers I and j. So here we will have two for loops. I will start from n minus 1 and it will go up to it's greater than equal to 0 and will decrement the ith pointer. And we will have the jth pointer, we will start from m minus 1 and it will go up to it's greater than equal to 0 and we will decrement the jth pointer, correct? Fine. Now here you can see that we have to add a 1 to both of their length, right? Why? Because since here we are starting from n minus 1 index, right? And if the value present at my text 1, right? The value present at the ith index of text 1 is equal to the value present at the jth index of text 2. Then what we were doing? We were moving forward, right? We were incrementing both the ith and jth pointer. So the moment when my ith pointer is n minus 1 and my jth pointer is m minus 1, and in that case, if I'll increment my ith and the jth pointer, then it will give me a runtime error. That's why here we have to add n plus 1 and m plus 1, correct? So what we will do, and let's initialize these values to 0, okay? Now, if the value present at my ith pointer is equal to the value present at my jth pointer, then what we were doing? We were assigning the value at I comma j as 1 plus memo of I plus 1 and j plus 1, correct? What we were doing over here, you can see that whenever I was having the character of I and j as equal, we were incrementing I and j. So here also we are incrementing I and j and we were adding a 1 and here we are adding a 1. Now what would be the not take case? It would be that if the value present at my ith and jth pointers are not equal, then in that case, what would be my memo of ij? It would be nothing but the max of memo of I plus 1, that is, and j, that is, we are going to skip the characters of text 1, right? Here you can see that what we were doing is we were skipping the characters of text 1, that is I plus 1, and j will remain as it is, comma, memo of I will remain as it is, and we will skip the characters of text 2. Here you can see that I will remain as it is, and we'll skip the characters of text 2, correct? And finally, what we have to return is we will return memo of 0, comma 0. Now let's run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity of this code. So the time complexity and the space complexity of this code would be n cross m. Why? Because here you can notice that the first for loop, the outer for loop, is running for a time complexity of order of n, right? We are iterating n times, and the inner for loop is iterating m times. So it would be nothing but n cross m, right? And the space complexity is also n cross n. Why? Because we are creating a vector of vector which has a size of n and m, right? N plus 1 and m plus 1, which is nothing but n cross m only. So that's all about today's daily LeetCode challenge. Thank you.